Hey guys, it was good seeing you in our chat. Here's our next lesson, which is on section 3.2, and then we'll have a little quiz on section 3.2 on Monday or Tuesday. So, in your next class. But in any case, let me just do some of these problems that I did in our chat. One's similar to that anyway, just to show you how this works. Remember that the log asks you a question. And it asks you this question it asks, and write this down, even if you have to pause the video. 7 to what power makes 49? This is another way of writing the number 2. So, you could actually go into the pizza parlor if it were open and say, hey, I'd like a log base 7 of 49 slices of pizza and a Diet Coke. And that would actually mean that you would be asking for 2 slices of pizza. See how that works out for you. This one says 81. So really, this one up here, we could say 7 to what power equals 49. This is the exponential equation. That's the logarithmic equation. They're equivalents, but they look very different. But they mean the same thing, and they have the same value. So this one says 81 to what power equals 9. Now, the square root of 81 would equal 9, right? And the square root is a 1/2 power. So 81 to the 1/2 power equals 9. So this thing is the number 1/2, or 0.5. This one here, this really says 4 to what power equals 4 to the 6th? Well, x would then have to equal a 6. Doesn't that make sense? 4 to what equals 4 to the 6? Well, then x is equal to 6. So the answer to this one is a 6. For this one, this is really supposed to be in the exponent position like this. This one doesn't look that good. It's supposed to be up there. Looks like it's next to it. This is what it's supposed to look like. This one will use one of the properties that are in your book in section 3.2, and if you go back to section 3.2, I'll tell you exactly what page it's on. It is on page 461, and on page 461 there's a yellow box there that will give you, for natural log and the common log, which they call the general properties and the natural properties, and give you this. And this is the fourth one down on the list under the general properties. So if this number and this number are the same, the answer just comes out to be a 23. Let's see if this makes sense. If we set this equal to x and say, well, what does this equal? And then changed it to logarithmic form, because right now it's really an exponential form, it has an exponent. We would say the log of base 7 of this number x equals, and the log always equals the exponent, log, and this would be the exponent out here. And it says log base 7 of what equals log base 7 of 23. Well, this what has to be a 23. So think about what that means. Also write this down in your notes. Maybe this will help you. If we have a base, just say call it a, right? And if we call this base a of some number b and it equals c, the log always equals an exponent. So we say a to the c equals b. This is the exponential form, this is the logarithmic form, and we should be able to switch back and forth between those two. Those will be test questions. This one here, ln, really remember ln means log base e. So this is another way to write this. Although they use this all the time, they never use this form. This one's a little bit easier to understand. So what this is saying, if we want to find out what this is, we would say e to what power equals e to the 7th? Oh, so x would have to be a 7, so the value of this one would be a 7. And we'll see some more properties in our next lesson after your test about that would even simplify this for us. This one here would be the same thing. If we wrote this in exponential form, it really says, so this really says log base e of e to the 13 over x. So really this says e to what power equals e to the 13x. We should have used another letter like y here. So therefore y would equal 13x, and it's always going to work out that way. We'll see one of our properties. When you have a log of something with an exponent, you could actually multiply that exponent out front. We'll talk about that next class. And this one, we're going to look at this page 461 again, and again it's the fourth property. Take a look at that, even if you have to pause the video. Go down to the fourth property. It says e to anything is going to equal that thing. So they say that e to the ln of x, ln of x, is going to come out to be x. And again, if we said, well, let's set this equal to y, and say, how would this work? Let's rewrite this by using this property here. Right now, it's an exponential form, even though it has a log in it. But we can write log base e. See, we're gonna change this from, this is the base, the e is the a part, the c is the exponent, right, which is always going to be the answer in the log. So this will be ln of 7x squared. And then the y is going to be next to the log. So you see the b, which is out here, is going to be next to the log. And then the a is the base, which in this case it's e for us, so it's the base. So I'm changing it from this to this. And then the exponent, the c, is always the answer. So it comes out here. So really this is saying log base e of, and we're trying to find out what y is now, equals ln, we'll write it as log base e of 7x squared. So therefore y is just going to equal the 7x squared part. So as you do more and more of these, you'll get better and better at it. But you have to do them all. So do all these odds. Check your answers in the back of the book. If you have questions, you could email me and let me know. And then you'll have a quiz on this on Monday or Tuesday, whenever your class is. So have a good night. I'll talk to you soon.